Welcome to the So, You Want to Be a Data Scientist podcast. Here we interview awesome data scientists and other data professionals. This show is part of the website soyouwannabeadatascientist.com. After listening, take my free data science Kickstarter course to learn what it takes to become a data scientist. In the meantime, enjoy the episode. Hello, everyone. Welcome to the new episode of So You Want to Be a Data Scientist podcast. I have Sakshi Mishra with me today. She's joining us from Denver, Colorado, and she's a researcher at National Renewable Energy Laboratory of the United States Department of Energy, which is a mouthful, but welcome.
Thank you. Thank you, Mishra, for having me here. Pleasure to be here and excited to share my experience so far working in the data science field. Thanks for having me.
Yeah, thank you for being here. I'm also very excited to start asking you questions. So let's start with the first one. I want you to first introduce yourself a little bit. Can you tell us what you do with your own words?
Sure. So, starting from a little bit behind from my studies, so I'm by study an engineer, an electrical engineer, and trained as a power systems engineer. And I call myself a data scientist from curiosity. But right now, my work, day to day work at office, is data scientist. So it's like starting out from electrical engineering, moving into data science field, and blending them both. As a researcher, is what my I guess the title is. So that was the short answer, but in terms of long answer, I think what I'm working on is taking the field of data science, the knowledge of data science, and applying that to energy systems to solve the problems related to climate change. And that is to say the main area I focus on is in energy system modelings, where we want to bring in more renewables onto our power generation mix. And from bringing them in and for integrating those high levels of renewables, we need lots and lots of challenges to be sorted. And that's where I use data science, the power of data science to solve those challenges related to that integration. So that is what is my overall, I think, overarching goal of my job is to use data science for energy systems and bring in more renewable energy onto the grid.
Wow, that's very interesting. So you have basically a certain goal that you want to achieve, and you're using data science and the techniques that come with it as a tool, basically.
Yes, yes, that's it.
Yeah, and is that your main tool that you're using? Is like data science and machine learning tools are your main approach?
Yes, I would say 60 to 70% of the time, data science and machine learning are the tools or methodologies I use. And then another part of it is optimization, which is a little bit more math oriented. But if you look at the umbrella of AI or data science, optimization is also one of not so trendy, I would say, but one of the approaches which is used.
Yeah, I can imagine. And you already mentioned a little bit your background in engineering, but can you tell us a little bit of a longer journey of how you ended up where you are right now?
Yes, sure. So I started out as an electrical engineer, and that was in India. I got my bachelor's degree there, and then I moved to United States to get my master's degree, and the field was energy science, technology, and policy. I know it's a long degree name, but that's how it was. It was an interdisciplinary degree. And I went to Carnegie Mellon University to get that degree. And for those of you who know about Carnegie Mellon University, it is like one of the top universities in the world for AI and computer science. So just being there and taking a couple of classes, I got a taste of this field and then found many follow-up opportunities to work with students on different data science projects. So that's where I got introduced to the field of AI. And then on, after graduating, I actually joined electric utility as a full-time grid planning engineer. But then I kept on taking classes online on Udemy and Udacity to learn, like, keep honing my data science skills more and more. So 2.5 years into that job, I realized that I do want to apply the skills I'm learning through all the data science courses into the work I do. And that's where I pivoted to the researcher role at National Renewable Energy Laboratory, where I get to use data science as a tool every single day in the problems I'm solving in the energy systems domain.
Wow, that's a hell of a journey, I would say. Pretty cool. So you basically got your official training in Carnegie Mellon, but you also complemented it with online courses.
Yes.
Yeah, that's very nice. So okay, let's talk a little bit about the kind of work that you're doing right now, specifically the projects that you're working on. So you said you are working on projects related to energy and renewable energy, but can you give us some examples of specific projects that you worked on?
Sure. So it's a variety of projects, as my role allows me to actually participate on more than 5 to 6 projects at the same time, and
Wow.
4 out of them are based on data science. So I'll pick a nice example of deep learning. Maybe that's a good application to talk
Mm-hmm.
about. So that's about forecasting the campus load for different buildings. So the laboratory I work in has multiple buildings, so it forms a big campus where each building has their own different kind of load profiles, depending on whether to have do they have rooftop PVs on there, or number of occupants in the building, or maybe outside temperature. All these things impact how much energy is consumed by a given building within the campus. And then why do we need to predict it is a question. Like, why do we want to know what will our consumption be in coming 5 hours or tomorrow? That's for optimization of the assets. Like, um, I'm trying to make sure I stick close to the data science aspect of it and not much of energy systems. So I would say there is a need for knowing what will be your consumption 2 hours from now, 5 hours from now, or even 24 hours from now. And for that, deep learning is one of the cool techniques I have been using, and it has given a lot good results when I compare them to the statistical techniques like linear regression for prediction. So what I'm doing is I'm taking in input features like meteorological variables and previous or historical energy consumption, and then feeding them for like 1 year worth of data to my LSTM networks, and then getting the energy forecast for upcoming hours through that network. So that's kind of one of the cool applications I have worked on. So another application recently I worked on is metadata tagging. So it is essentially like in buildings, we have lots of control systems data which comes in through sensors and controllers, which sense room temperature or energy consumption or occupancy, or how much current is this device taking. All these data are kind of, there is a network which is built within the buildings, which is called building automation system, that gathers the data, and then it's like a raw data basically, with no tags or no name, like no human readable tag names or column names. So that data comes in, and now one engineer has to sit who knows about buildings and then tag it manually. So that's where we saw the opportunity to apply machine learning to automate that process, where we take the raw data and then use both sets of supervised and unsupervised algorithms to tag it, and form a metadata layer on top of it, which is saying, okay, so this data stream or this time series data, it seems like it's measuring air, and it is measuring and not controlling, and then it is measuring it on floor number 5. So all those fields get tagged to one time series data. And that tagging process, we have automated it using like machine learning algorithms. One was SVM, and then in unsupervised it was k-means clustering we used to associate, to first cluster out the different time series, into the ones which we think, okay, these all belong to some kind of sensing of how much airflow is in this room, as an example. And then so working through those, it's like feeding the decision from one algorithm to another to inform it better. And then at the outcome, we are creating automatically metadata for the all the raw input data points which we get from various parts of the building.
And yeah, it also sounds like, when you tell me someone is a researcher, I always kind of assume that what they're doing will not have much application, not because it's bad, but because it's like research oriented. But I feel like what you've been describing is highly applicable to real world, and you are applying it to real world. It really has practical applications.
Yes, that's true. I think that's kind of it also depends on the kind of position. So for me, it's called integrated application center. So my job profile is such that I focus on building such applications which are very close to real time deployment. And there are a few researchers they are working on trying to, let's say, make solar panel more efficient. So that is in a pipeline, and maybe 5 years down the line you will be able to produce such solar panels on a mass scale. But for me, since my profile is such that I work on data science as a tool to do things, it's not hardware specific. It's more like as long as I have a working code, I can build the prototype and show its application. So that gets me closer to real time deployment. That's kind of one of the fulfilling aspects too, that I get to see as a researcher. I'm building something, but it is also getting deployed.
Yeah, that's very cool. I think that's one of the reasons that people very like data science, that they can see the results really fast and improve it if there is a need.
That's true.
So you mentioned that you sometimes get up to 5 or 6 projects. So I'm very curious, how do you manage these projects? For example, what do you do every day? How does a day look like for you?
Sure. So I think it's like I divide my tasks into 3 or 4 buckets. One is actual coding, getting to the problem. Second is collaboration part, where because for a data scientist to be able to code something, you have to very thoroughly know the requirements of what is that you're trying to achieve. And that's when we get to the part of actually building a solution. So it's like in the collaboration buckets, I have 2 or 3 meetings where one, either I'm meeting with folks who are placing the requirements, this is what we want to achieve from the project, or two, from the folks with whom I'm collaborating, that this is your task. Will you be handling the uh, raw data cleaning aspect, and will you be handling the testing and evaluation aspect? So that's like the collaboration bucket. Then one is the coding bucket of, okay, these are my 3 hours of 3 or 4 hours of dedicated deep work. That's kind of the term we use of the coding part. And then there is third task, and I think that is kind of unique to my role, which is researcher, is to actually like publish it. So once I have the results, I spend good chunk of time coming up with the manuscripts and then different test cases to show the effectiveness of the method or the approach we have taken to reach results. So that's how kind of I divide my day.
I see. Yeah, that sounds very nice. I especially liked when you mentioned deep work, right? Yeah, it's I don't think it's very valued in industry, but it's very nice to hear that you guys even have like a name for the period of time where everyone does their hands-on work or like very serious focused work, because I think that's very important to be not be distracted and have that special time for work, the type of work that you have to sit down and be focused and be really present.
Yes, yes, it definitely adds a lot of value in terms of our productivity too. So that's a good thing, I think, which should probably be adapted in all industries to increase the productivity.
Yeah. And you mentioned that you have one part of your work is with meetings and everything. And so is that kind of like you are part of a team that is working on a project, and that's kind of the team meeting? Or how does the structure of working together is happening there?
Uh-huh. So it's like there are two aspects to it. So if we talk about my work being people facing, so there are few aspects of it where I'm working with the, let's say, decision maker who wants to deploy the tool, but they're not really the technical people who know like beats of how modeling works. So that's one part of it. And the second part of it is the collaboration with folks who have the similar skill set and who are helping me hands on in the project I'm doing. So the first part is where the communication is always higher level. We are not talking about, oh, which LSTM or RNN model are you applying? No, those are not the questions. They ask the question, what is that you will be predicting? How much accuracy increase do you think it will see? How much time and resources will it cost us to actually take your prototype to deployment phase? So those are the questions or the dynamics which go between as a data scientist or researcher and the decision maker with whom I'm working. And then there is second people facing aspect where I'm working with, let's say, graduate interns or another senior researcher who are and we are kind of dividing the task and trying to understand, hey, do you know about that data source? How will you get it there? Okay, cool. So am I going to be working on the aspect of determining which all input goes into the model, and then reporting, let's say, writing the unit tests which validate the initial prototyping. And then maybe the graduate intern, I ask them to, hey, do you mind just write like rerunning the test with different test cases to see the results and then plot it for me? So that's kind of the collaborative, technical collaborative environment I work in as part of my job.
I see. So basically, we can say that you have a team on projects, so you're not just working on it alone.
Yes, that's correct. It's always a teamwork, I guess.
I see. I see. And how does these or how do these projects come to be? Who comes up with the ideas?
So there are two ways of coming up with ideas. One is like external demand, where we hear, and I think the first one is kind of close to the research industry, where we hear that Department of Energy has a call for funding to answer the question that how do you utilize machine learning for better optimization of energy dispatch. So those are like the ideas trickling down from outside, and then we come up with our solutions and show them, not the solutions of building the code, but higher level solution of this is how we plan to implement, and then we propose it. And if that is accepted, funding comes in, and then we work on it. Versus the second set of ideas, where as a team, or sometimes it's just one person. I'm, for example, right now I'm working on building an idea of applying reinforcement learning for building controls um, question. And for so that's something bottom up approach, where I'm typing something up, whatever is in my mind, and mind mapping it, and then getting together with two more researchers and then getting their input. And once I have my proposal ready, that's when, so there are two aspects to it. One is technical proposal is ready and I really want to work on it. Second is how do you get time or resources to work on it. Basically like letting your organization say that your 30% of your time or 40% of your time will be spent on this idea, which means which gets directly tied back to the funding source. So I would say that's one aspect. If working for an organization and not as an independent data scientist, it's something which comes into consideration, and we realize it when we are within the system that wanting to work on a specific project, which is our own idea, we need to know the idea selling part too. That how do you convince decision makers to allocate funds for you to work on that specific idea you have. So yeah, so I would say to summarize, there is one thing which is top down approach, where there are funding calls and we try to answer the question using our knowledge of data science. And second is like, I have this idea and how do I get it funded through decision makers to make it happen. So I kind of work on both the paths.
Yeah, that sounds like a very kind of like a dream job, actually. It also sounds like, you get to use a lot of your creativity and you have a lot of freedom to decide which approach you're going to use, what type of solution you're going to implement.
Yes, that's true. So maybe it's just my experience as a researcher, or maybe it's a solution everybody can employ in their job, but it's really about what gets done. If you think about it, like I am going to work on this project, and what it gets you is 20% increase in accuracy. If that's the quantification, the person who has idea, if I can give that kind of quantification to the decision maker, the probability of getting it approved always increases. So if it, and I'm sure it depends on the types of organizations you're working on, organization you are working in. I am in a research industry, but maybe typical data scientist job, they really should be identifying the business pain point. If they're able to identify, okay, this is where the business is struggling, they really want to know how do these things, like let's say a supply chain industry example, perhaps, that they really want to be able to predict the demand for that geographical location better. Can I come up with an idea which can solve that? And if that is the kind of framework you are setting behind the project you really want to work on, I'm sure this can be kind of generalized into other industries as well.
So let's talk about a little bit about how you manage your specific tasks. So, on a typical data science project, you have this period where you have to collect the data or maybe get it from a database, let's say. Then you have to do a data understanding and data exploration. Sometimes even you have to clean the data and then do modeling, right? And then you can also tune the model and then maybe even deployment. So data science explanation changes, sometimes includes deployment, sometimes doesn't. And how do you separate these tasks time wise? Like, I hear many times that people say the data cleaning part takes like half their time. How does that work for you?
Yes, that's a very good question you asked. It's like for a data scientist, as you say, it's like first thing I have to make peace with is initially a lot of time is going to spend in just determining the data source, then cleaning up the data and making sure this is the data you want to use to answer the question you have in hand. So I do spend, I would say, a good chunk of time going through that process. But before that, more importantly, I try to refine my problem more to understand, like, is it the data I really need? And if so, then how do I go about making it better for the problem? So the roots really lie into the question that, are you able to understand the problem well? Because it's easy, usually it's easy to just assume, okay, this is two sentences defined for the problem, and it makes perfect sense. But if you think deeply more about it, it may turn out that the data you need or the data you should be cleaning is altogether different than what you thought initially was required. So that's one aspect of it. But then second aspect, as you say, in terms of actual day-to-day work, it takes up my time, but I feel like most of the time it also depends on the seniority level. That's one thing, that if you have a graduate intern working with you, you are mentoring them, so that's kind of delegation comes into play, where you can work with them to do that. But yeah, at times I am also working on it. So, and I think one other point to add there is, it's the process, meaning the more number of times I have gone through the process, there is a unique way of thinking I have learned to develop in my mind, that okay, given that problem, given this data, how do I approach the cleaning part of it? So I get more productive or more efficient as I do it more number of times. So it gets better with time. That's, I think that's how I would say, the more number of times we have done this task, the easier it gets. But yeah, this is one of the things, one of those things which comes as a baggage, that you have to be knowing how to clean the data, and you have to be willing to do that if you are working on a data science project.
Yeah, I definitely agree with your point that it's really affects how you clean the data to know, to understand the problem properly and to know what you're going to need in the future. Because even in the data cleaning process, you have to make a lot of decisions and assumptions. And if you don't really understand your problem well, it might cause problems in the future.
That's right.
And so, okay, so you're a researcher. So I'm thinking typically you would be delivering articles, academic articles. But I also want to hear from you. Is there what is the typical deliverable of your projects? Do you do anything other than publishing articles?
Yes. So, as a researcher, I would say I am just kind of super lucky in the sense that I have all the varieties. So, yes, my primary deliverable is research paper, but also the prototyping. So, right now at National Renewable Energy Laboratory, we have a program called Intelligent Campus Program, where we are working on prototyping the research. So, for I earlier I discussed the example where load is being forecasted. So that prototype I built I actually got paired with a software engineer who works within that program to deploy it for one of the buildings. So that was like real cool, meaning I was able to deploy, get that working. But I would say, like, in terms of deliverables, prototypes are something which are pretty much common these days, where we are working on an idea, and there is a code which is required. It's not just some abstract question I'm trying to answer. Then we are always expected to show a working prototype, which may not be like always essentially something which can be scaled out just in 2 months, but still a functioning prototype which shows what's the input, what's the output, and how's the efficiency of the whole process. So I would say articles, prototypes are solution prototypes are two main deliverables, but at times I get lucky and I get to deploy them also.
Nice. And who are the people you are presenting these results to? So, okay, articles are sent to journals or academic bodies, but who are the receivers of these prototypes, for example?
Yeah, so for that, NREL, or National Renewable Energy Lab, has a system where we do strategic partnerships with industry partners. So recently, another project I was talking about, which was metadata tagging using machine learning. So for that, the funding came in through an industry partner who wanted us to build that, and they are actually, yeah. So they took our prototype and they did some more like finishing touch, and they did deploy it in real time. So many a times our audience are industry partners who want to take a cutting edge research solution into their production pipeline. So that's like one of the primary audience. And then second, for the project I was talking about, which is load forecasting and deployment within NREL campus, for that our audience is really the leadership of the organization, looking at how we are able to take our research, because we are primarily a research organization, and able to deploy it and show that's something I think uh, pretty much a lot valuable within the organization too.
That's very nice. It must be amazing to see that you're doing some research and then it is being applied in the real world. Yeah, I'm sure it's very exciting.
Yes, it is definitely.
So I also want to know about the typical tools that you're using. So right now you're a researcher and not like a data scientist. I mean, you also have the title of a data scientist, but you're not like a data scientist in industry. But your main tools are AI and machine learning tools. So I want to know what specific programming languages or type of software that you're using as part of your work.
Sure. Yeah. So I would say like the line is blurry here. I use Git for version controlling, PyCharm IDE for my prototype development, Python as a programming language, PyTorch library for deep learning projects, and scikit-learn for machine learning projects. So it's almost overlapping with what gets used in industry. But I think the difference really is the optimization in terms of speed of data cleaning. I'm always not specific that I should be using NumPy. Maybe it's okay to stick with pandas and do the operation on the column right away, rather than changing it to NumPy and then for the faster operation. So that's where the little bit of difference comes in between prototyping and production, where I'm not hyper focused on maximizing the efficiency of the coding itself, but more focused on just the modeling aspect of it. As long as I'm getting data in, it is getting cleaned. I am not super bothered about how fast it is running. But in terms of tool, it's pretty much overlapping, I would
I
say.
see. Yeah, that makes sense. Nice. So I also want to know how you feel about your job a little bit. I mean, I keep saying that it sounds very amazing, but what is the thing that you like the most about what you do?
Um, there are many things, but I would say in terms of day-to-day operation, as an energy researcher slash data scientist, the one aspect I enjoy the most is novelty. It's like every single project I have worked on so far is always different than others I have worked on. So approaches and methodologies required to answer specific questions are kind of always different, even if it's the same algorithm or same. Let's say I want to apply LSTM, the question doesn't end there. Like, how do you think about the inputs and outputs, and what are the implications? So that brings a different flavor to every single problem I solve. So it kind of keeps me on my toes always. So something new to learn every single day, and it doesn't seem like that I'll reach a plateau anytime soon. So that's one aspect I enjoy from my day-to-day operations. And I think second point is in terms of meaningfulness. So as I had mentioned earlier, I kind of use data science as a tool to achieve something, and that is my contribution to the climate change problems of the world. And energy systems is my field of interest. And so the big problem or big picture is climate change. How I am contributing is through making energy systems more clean, integrating more renewable energy, and the tool I use is data science. So that kind of makes it more fulfilling because it has like a meaningfulness aspect associated with it where I know that I'm contributing to the sustainability of the planet.
Well, I can definitely hear how excited you are even from your voice. But it does sound great. Yeah, you're basically doing something that is valuable to you using a sort of tool that you're excited about, and that's basically the best case scenario, I think.
I think, yeah, I got pretty lucky.
Yeah, yeah. Nice. And okay, is there anything that you don't like that much about what you do, or something that you like the least, something that bugs you?
Yeah, I think in terms of energy domain specific thing, I feel like at times data is not made open source. So there are some times or some research studies where I build a ML based model and I prepare the manuscript describing the method and results, but I can't make the code or the data publicly available. So that's the nature of, I think, energy field per se, because it's a critical infrastructure field and there are restrictions onto how can the data be publicly distributed. So that's one thing I feel like there is need for more open sourcing in this whole domain. And there are efforts in place. People are trying to bring this thing to the surface, that if we are able to make the data open source or the code bases themselves open source, then we have more and more people contributing to them, making them better. But right now it's kind of constrained. So that's something which bugs me. And then another part is, it may be because of the nature of my job as a researcher, but it is like the roles are a little bit overlapping. So the project life cycle, which starts with model exploration, then model refinement, then testing evaluation or deployment, and then continuous monitoring and maintaining. So my the thing I love to do is model exploration and refinement and building the testing evaluation, but at times I have to get tightly integrated with the deployment aspect of it as well, and then monitoring and maintaining. So that's where it's like there are 3 or 4 people in the team, but the roles are not that much clearly defined, and sometimes they overlap. So that kind of little bit I would say problematic, but not really that much. Meaning, once we communicate it also boils down to communicating better and then defining, okay, this is where I stop, and that's where the monitoring and maintaining person takes it up. So that's, I think, something which could be a little better.
I see, I see. But that still sounds great. And I think you're not alone in preferring model development than model maintaining. I don't think many people like that part. And one other thing that I want to know is if you have ever encountered any bias in your work. It doesn't necessarily have to be in your current job, but also in your career leading up to this point or while you were studying, because, basically women are highly underrepresented in technology and especially in research. So have you ever encountered anything unpleasant?
Yes, in the beginning, actually. So, growing up, I grew up in India. It's a developing country. So when I was about to choose my major for my bachelor's degree, I was told that you shouldn't be doing electrical engineering because, machines are not for girls. You just do some software engineering work. So though I liked computer science and electrical engineering equally, I went with electrical engineering just because they said I can't do it. I said, fine, let me show how it works. So I think that was the beginning of it. But after that, in terms of like external barriers, I haven't faced as many. And again, I think I just got lucky that I get to work with people who never differentiate between uh, whether I should be given an opportunity or not just because I'm female. But I would say one thing which kind of bugs me is that at times there are whole day there are 3 4 meetings and I'm the only woman in the room, and it's bad, it's sad, right? Meaning female representation should increase. And there is, because human mind is mind, it works the same way, whatever gender it is. So why is it so that females just don't contribute in this field? Like, and I'm not saying that they do not want to. There are some inherent biases built in here and there in many different parts of the whole process of raising a girl and then having her educated in this field and then keep moving forward in their career progression in the field. There are biases that kind of prohibit the strong or majority involvement, and that's something I think we as females who are in the field can help make better, maybe by setting up role models or increasing the awareness and then showing that, just communicating that, hey, you are valued here, every single person, female, male, minority, whoever, you are valued and you're welcome to join the table. There's a seat for you. So those are the things I think we can do better going forward to decrease this issue of bias.
Yeah, definitely. I think, yeah, that's also part of our job right now to be role models for future women, or as you said, people of minority, and to tell them that they're welcome and there is nothing standing in their way to become whoever they want to become or study whatever they want to study.
That's true.
So I
Yeah.
definitely agree. Okay, so my final question is if you have any advice for people, for someone who wants to be where you are right now, or someone who wants to get into a data career like you did.
Sure. So I would say everything starts with curiosity. I think that's something, I wouldn't say it's understated, but it's usually like, oh, curiosity is a starting point. It's taken easily, but no, it really is the starting point. Meaning, if you're curious and if you want to keep moving in the direction, then you have to start with curiosity. And then second aspect of it, do not let your past define who can you sorry do not let your past define who will you be in the future. So I came from an electrical engineering background and I was working in a electric utility, which is kind of altogether different skill set. But starting from my master's degree education, I kept building my foundation of data science skills day by day, month by month. And then until I reached a point where I was able to build a prototype and then be able to show the results. So just because you were in a different field doesn't inhibit you from being in data science field. That's the beauty of it. There is lots of online resources available. You can train yourself and then you can show on, let's say, just one repository on GitHub showing this is my work, I have done this so far, which enables you to enter this field or professionally enter this field basically. So I think that's the one advice. And I guess second one is really just that, do not let your past define your future. You may have been an altogether different field, or maybe you never really did programming, but that does not decide that you cannot do it in the future too. It's just really the function of willingness plus effort which gets you there.
Very good advice. And that's one of the main advice that I've been trying to also convey to people. And I totally agree with you. It's very important to just, believe that you will be able to do it. There is literally no reason for anyone from any background to not be able to be a data scientist, I think.
Yes, definitely agree on that one.
So that was my last question, actually, Sakshi. This was a very fun conversation and also a very informative conversation. So thanks a lot for it. And I enjoyed it a lot. And I hope our listeners enjoyed it too. So thank you for coming on the show today.
Thank you. So glad that you found it useful, and hopefully users find it too. And yes, cool. So thank you for having me here.
Yes, thank you. Hey, thank you for listening, and I hope you enjoyed this episode. Don't forget to take my free data science Kickstarter course to learn what it takes to become a data scientist. See you next time.